Hello guys, in this lesson, we will see the basics of protocols and layered models. All communication has three elements: the source, who is the sender, destination, who is the receiver, and the channel, who is the media. All communications are governed by protocols, and those protocols are rules that communications must follow. Let's move to the definition of rules. We need to use established rules or agreements to manage the conversation. The first message is difficult to read compared to the second, because it's not formatted correctly. It's very important to format well. It will be easier for users to understand. Let's move to the message encodings. Encoding is the process of converting information to another acceptable format for transmission. However, decoding reverses this process to interpret the information. The format of the encoding between the hosts must be adapted to the medium. Messages sent over the network are converted into bits, encoded in a pattern of light or electrical pulses. The destination host receives and decodes the signals to interpret the message. Let's move to the format and encapsulation of messages. When a message is sent from source to destination, it must follow a specific format or structure. Message formats depend on the type of message and the type of channel used to deliver the message. Let's move to the message segmentation. A long message must be divided into small pieces to circulate on a network. Sending smaller items makes it possible to intertwine many different conversations on the network. This is called multiplexing. Each chunk is tagged and sent in a separate frame, each containing addressing information. The recipient will reconstruct the message from multiple frames. Let's move to message synchronization. Message synchronization includes access method. It's when hosts on a network need to know when to start sending messages and how to respond to errors. Flow control. It's when source and destination hosts use flow control to allow proper synchronization to avoid overwhelming the destination and to ensure that information is received. Response timeout. It's when hosts on the network are subject to rules that specify how long to wait for responses and what action to take if the timeout occurs. Let's move to the message delivery options. Message delivery can be one of the following methods: unicast, who is one-to-one communication; multicast, who is one-to-many communication, usually not all; and broadcast, who is one-to-all communication. Let's move to the protocol functions. Protocols can have one or more functions like addressing, who identifies sender and receiver; reliability, who offers a delivery guarantee; flow control, who is ensuring data flows at an efficient rate; sequencing, which are uniquely labels each transmitted data segment; error detection, who determines if data was corrupted during transmission; and app interface, which is process-to-process communications between network applications. Now I will explain to you what is a protocol. The transfer of information requires the use of several protocols. Each protocol has its own function and its own format. HTTP, Hypertext Transfer Protocol, governs how a web server and web client interact. TCP, Transmission Control Protocol, handles one-to-one conversations and offers delivery guarantee. IP, Internet Protocol, allows global routing from sender to a recipient. Ethernet, allows routing on a local network. Let's continue with the TCP/IP protocol. TCP/IP is the next protocol used by the Internet and includes many protocols. TCP/IP is an open standard protocol, freely available to the public and can be used by any provider. A standards-based protocol is endorsed by the networking industry and a standards body to ensure interoperability. Let's move to open standards. Open standards encourage interoperability, competition, and innovation. Standards organizations are vendor neutral, free for non-profit organizations, and created to develop and promote the concept of open standards. Now let's look at Internet standards. We have the Internet Society, ISOC, who promotes the development, evolution, and free and unrestricted use of the Internet. Internet Architecture Board, IAB, HOW is a committee responsible for the management and development of Internet standards. Internet Engineering Task Force, IETF, who is used as a working group to develop, update, and manage the maintenance of Internet and TCP/IP technologies. Finally, we have the Internet Research Task Force, IRTF, who is a working group focused on long-term research related to Internet protocols and TCP/IP. Let's move to the following of Internet standards. Standards organizations are involved in the development and support of TCP/IP. Internet Corporation for Assigned Names and Numbers, ICANN, coordinates assignment of IP addresses, management of domain names, and assignment of other information. Internet Assigned Numbers Authority (IANA) oversees and manages assignment of IP addresses and management of domain names and protocol identifiers for ICANN. Let's move to electronic communications standardization bodies. In the image to your right, we can see many communication standards. I will explain the functionality of each standard. The Institute of Electrical and Electronics Engineers, IEEE, is an association dedicated to technological innovation and the creation of standards in several areas including networks. Electronic Industries Alliance, EIA, our standards for electrical wiring, connectors and network racks. Telecommunications Industry Association, TIA, which are standards for radio equipment, cellular towers, VoIP devices, and satellite communications. International Telecommunication Union Telecommunication Standardization Sector, I2T, our standards for video compression, Internet Protocol Television IPTV, and broadband communications. Let's move to the layered models. A layered model is used to easily explain the complex concepts of how a network works. Two layered models describe network operations. We have two main layered models, who are OSI reference model and TCP/IP model. So, what is an OSI reference model? A layered model makes it possible to divide all the operations required for a transfer of information between two applications located in two terminals interconnected by a network. These operations are divided into several processes called layers. Each layer is therefore responsible for part of the operations. We can see all the elements in an OSI model in the picture below. Let's check what is an TCP/IP model. The OSI model is a theoretical model, written and standardized by the ISO standardization body. Similar to the OSI model, the TCP/IP model was created following an actual software implementation of the treatment processes required to transfer information between applications held in separate terminals. The application layer of the TCP/IP model comprises the operations of the higher layers of the OSI model, and the network access layer, the operations of the lower layers of the OSI model. Let's move to the protocol data units. Each layer has a protocol associated with it. A protocol is a software implementation of the functions associated with a layer. In turn, each layer's protocol adds a header containing information to help it perform its task. The process of adding headers is called encapsulation. The block of data for a layer is called PDU, Protocol Data Unit. The PDU has a well-known name for each layer. We have the application, which is data, network, which is a packet, transport, which are segments, link, which is a frame. Finally, we have the physical, which is bits. Let's move to encapsulation. A web server sends data to a web client, browser. The encapsulation procedure is as follows. First, the web server prepares the web page, data. The HTTP application layer protocol adds an HTTP header specifying information about the web page. Second, the transport layer TCP protocol segments the data, adds a header to identify each segment and the destination application. Third, the network layer IP protocol adds the IP addresses used to route data across the internet. Fourth, the link layer Ethernet protocol adds the MAC addresses used for routing in the local network. Finally, the physical layer transforms the frame into bits and transfers everything to the physical medium. Let's move to decapsulation. On reception, the PC processes and deletes each header in reverse order. First, Ethernet header is removed. Second, IP header is removed. Third, TCP header is removed. Finally, the data, the HTTP header and the web page, is sent to the browser, which uses the HTTP header and displays the received web page. I will show you an example of encapsulation. Let's check what's an HTTP protocol header. The HTTP protocol governs how a web server and a web client interact. To do this, the HTTP header includes different values. We can see all the values in the image, which is down in the right corner. We have the response message containing the requested page, the date of the response, the open source web server software, which is Apache, the date of the last modification of the page, the length of the content and the type of the content. Let's move to the TCP protocol header. The TCP protocol manages individual conversations, multiple applications and guarantees delivery. To do this, the TCP header includes different values. Source port is for web server. Destination port, which is used so that the client on the browser can hear. Sequence and acknowledgement number, which is used to guarantee data reception. Finally, we have checksum, which enable transmission errors to be detected. Let's move to IP protocol header. The IP protocol allows global routing internet. To do this, the IP header includes different values. Source and destination IP address, who are used to route the packet through the internet. Protocol, which specifies the type of data encapsulated in the packet. Finally, let's move to Ethernet protocol header. The Ethernet protocol allows routing over a local area network. To do this, the Ethernet header includes different values. Source and destination MAC address, who are used to route the frame in the local network. Type, who specifies the type of data encapsulated in the frame. At the end of the frame, a checksum field ensures that there is no error in the frame. Thanks for watching this video, and don't forget to like and subscribe to my channel.